Hello and Assalamualaikum. My name is Nurul Nabila Binti Pandi and my metric number is 1910923552. Today I'm going to talk about chapter 1, which is introduction to our mini project. Our mini project is automatic water sprinkler. For brief introduction, a automatic water sprinkler is a device that used to irrigate agriculture crops, lawns, landscape and the other areas. This system also can easily control the soil moisture remotely by using moisture sensor and timer. For the problem statement, firstly, watering plant has become a burden in today's modern world. Secondly, the timer sprinkler installed in automatic water sprinkler is not effective. Lastly, water wastage that occur using automatic water sprinkler system. For our project objective, firstly, to supply water to soil so that moisture will be readily available at any time for crop growth. Secondly, installation of timer or sensor or probe system which operate based on presence of water. Thirdly, to increase water use efficiency. Next, to ensure maximum yield at optimum water utilization. And lastly, to ensure sufficient supply of water during drought of short duration and unpredictable climate.
Hi, my name is Siti Nabila Binti Abdullah and my matrix number is 19109052. In this video, I'm going to talk about flowchart and tasks of every member. For flowchart, we started with writing a proposal, and after that, we choose type of state diagram. It is milli or more, and then we proceed to write long report. But in the long report, consists of 5 chapters. Since we have 5 members, each member took 1 chapter. For chapter 1, Nurul Nabila. Chapter 2, Siti Nabilah. Chapter 3, Muhaimin. Chapter 4, Muhammad Haris. And chapter 5 is Sivaganeson. For chapter 1, Nabila need to do some objective and introduction. Meanwhile, for Siti Nabilah, chapter 2, flowchart and member task. Chapter 3 is run designing process, such as starting truth table. Chapter 4 Chapter 4 is run a simulation based on the design on chapter 3, and lastly is chapter 5, which is write a conclusion based on the whole process.
My name is Muhaimin and I will continue to present about system design in chapter 3. First, we will see the inputs and outputs relations. So in this mini project, we use 4 inputs, which is soil moisture sensor, timer, pressure water level sensor 1, and pressure water level sensor 2. So next, this is the input and output relation. For output, we use water sprinkler 1, water sprinkler 2, water level aggregator high and water level aggregator low. So next, we design our state table based on our assumption that have been made. So our assumption is the sensor will be active when the soil moisture is at low level or clock shows at 9 am opposed to be active at the same time. But the water must be at the high level, and no sprinkler will be active when water at low level. So this is the sensor that will function based on our assumption. So next, design the state diagram. So we assume S0 as all sensor is not active, S1 water level low active, S2 water level high active, S3 water sprinkler 1 active, S4 water sprinkler 2 active, and S5 both water sprinkler active. That's the output. So next, we design for design process. First, we make a truth table. So for truth table, we have present state, inputs, states, output, and flip-flop. So this table we designed from the diagram. So next, from the table we make a K-map. So from the table we can assume that all inputs will trigger the same output in each state. So K-map 2 times 1 have been made for all the outputs. Then for inputs, the flip-flop expression, we just simplify the equation using the Boolean algebra. So this is the expression for ZA, ZB, ZC, ZD. So this is the full of the SOP expression for the outputs. And lastly, from the expression we design the circuit diagram. So based in this circuit diagram, we have 4 inputs, S4, S3, S2, S1. S4 is the soil moisture sensor, S3 is the timer, S2 is the high level water sensor, and S1 is the low water level sensor. So we have 4 outputs also. ZA is the water sprinkler 1, ZB is the water sprinkler 2, Z6 is the high water level indicator, and lastly Z is the low water level indicator. So this is our circuit diagram.
My name is Muhammad Aris bin Gani. Today I would like to present to you about our chapter 4, which is results and discussion in our project, which is the automatic water sprinkler. In this chapter, I will tell you about the input and output functions, and then I will run the simulation in the digital lab software, and then I will explain to you the timing diagram briefly. Okay, this will be our circuit diagram. The first input, which is the low level sensor, and the second input, which is the high level sensor, and the third input, which will be the timer at 9 o'clock, and the fourth input, which will be the soil moisture sensor. For the output, the first output, which is the sprinkler number 1, and the second output, which will be the sprinkler number 2, and the third output, which will be the high level indicator, and the fourth output, which will be the low level indicator. I will try to run the simulations. For the first state, which is the normal state, when there is no input turned on, then there will be no output turned on. And then when the water is at low level sensor will be turned on. It indicates that the water is at low level. And then when the water is filled up, the high level sensor will be turned on, and low level sensor will be turned off, which indicates it's at high level. And then for the timer is at 9 o'clock, the sprinkler number 2 will turn on, and it shows the water tank will indicate it is high level. And then when the soil is dry, the soil moisture sensor will be turned on, and the sprinkler number 1 will also be turned on, and it indicates that the water is also at high level. When both sensors is on, which is the soil is dry, and the timer shows at 9 o'clock in the morning, sprinkler number 1 and sprinkler number 2 will also turn on, and the water shows that the water tank will show high indicator level. When the water is at low level, the low level sensor will be detected, and the high level sensor will be turned off. There will be no sprinkler will be turned on, and the low level sensor indicates to the water tank that it is low level, and water pump will fill up the water tank. So no sprinkler will be turned on, and the water is at low level. So it needs to wait until it reaches high level for the sprinkler to turn on back. So when the water is at high level, the high level sensor will be turned on, and the low level sensor will be turned off. And then it takes normal, the sprinkler will be turned on, and then the water will show high level. I think that's all for me, and thank you.
Hey, hello guys, my name is Sivaganeson, son of Kumarasamy, and my matty number is 1910923556. Today I'm going to present on chapter 5, project impact into society, and the conclusion. Automatic water sprinkler project will produce a huge impact on society and the agriculture industry in many ways. Firstly, it reduces employee and the cost. Besides that, this project produces more time irrigation. On top of that, it helping in the management of higher flow rates. Next, this project reduce run of water and nutrition. However, these projects are highly cost. There are costs in purchasing, installing, and maintenance of automatic equipment of irrigation system. As the conclusion of this project, the results show all the aim of objective are successfully achieved to this project. The automatic water sprinkler device was well functioned and according to the moisture remotely by using moisture sensor and timer. This system will work to minimize the number of workers in crop field and control and save the water. This project also helped to increase the agriculture production using a small quantity of water, minimize manually intervention in watering operation with increased watering speed. Thank you.